Hey everyone, in this video we're going to solve equations by factoring. So we're going to put together our skill of factoring with the zero product property to come up with the solutions of the equations that we're given. So our directions, pretty straightforward. Solve each equation by factoring. First equation, x squared minus 5x equals 0. So we can take a GCF from the left side of x, and then we have times x minus 5 equals 0. So we have the product of two factors equal to 0. We can use the zero product property, which allows us to set each factor equal to 0. As a reminder, right, if the product of these two factors is 0, one of these factors has to be 0, possibly both. So x equals 0, that's one solution. We'll add 5 to both sides here, so x equals 5. So our solution set is 0 or 5. Next up, we have x squared minus 81 equals 0. So we can factor this using the difference of two squares. Right? We have the difference of two terms, both being perfect squares. So we have x minus 9 times x plus 9 equaling to 0. So the product of two factors equals 0. That means at least one of the factors has to be 0. So x minus 9 equals 0, or x plus 9 equals 0. So that means x equals 9, or x equals negative 9. So our solution set, negative 9, or positive 9. X squared minus 12x plus 27 equals 0. So we have a trinomial. So using our trinomial factoring technique, so we need factors of positive 27, right, 27 times 1, that add to negative 12. So that would be negative 3 and negative 9. Right, let's just check that. So negative 3x minus 9x is negative 12x. Negative 3 times negative 9 is positive 27. Perfect. So product of two factors equals 0. So by the zero product property, either x minus 3 equals 0 or x minus 9 equals 0. So we have either x equals 3 or x equals 9. So our solution set is 3 or 9. Okay, and we can check this even in the previous examples. Take either of these x values, plug them into your equation carefully, and you should get a true equation. You should get 0 equals 0. X squared minus x minus 30 equals 0. So we have another trinomial. So the first thing that we need to do is factor it. So again, we'll use our trinomial factoring technique. So we need factors of negative 30 that add to negative 1. So that's going to be negative 6 and positive 5. Now we have the product of two factors equaling 0. So we can use our zero product property. So x minus 6 equals 0. Or x plus 5 equals 0. Adding 6 to both sides, we have x equals 6. Subtracting 5 from both sides, x equals negative 5. So our solution set is negative 5 or positive 6. Next up, 14x squared plus 7x equals 0. So looking at our equation, we can take out a greatest common factor of 7x. And that would leave us with 2x plus 1 equals 0. So we have the product of two factors, right? Technically that's a factor. So either 7x equals 0 or 2x plus 1 equals 0. Divide both sides by 7, x equals 0. Subtract 1 from both sides, divide by 2. So x equals negative 1/2. So our solution set is negative 1/2. Or 0. 2x squared minus 5x minus 12 equals 0. So again, we have a trinomial. Now we have a leading coefficient that's not 1, but it's still prime. So we should still be good to use our trinomial factoring technique. So we have 2x times x, so that's 2x squared. So now let's think of factors of negative 12 that when we distribute out, we get negative 5x in the middle. So let's see. If we try 4 and 3, we'd have 8x and 3x. So if I want -5, make that negative, that positive, that will do the trick. And again, you can always multiply this out to confirm that you are correct. And now we set each factor equal to 0 using that zero product property. So here we'll subtract by 3 first, and we'll divide by 2. Here we'll add 4 to both sides. So our solution set is -3/2 or 4. Perfect. Next up, 3x squared plus 20x minus 7 equals 0. So another trinomial. Still, leading coefficient is prime. So that's a good way to start. So we have 3x and x. Now 7 is also prime, so we either have 7 and 1 or 1 and 7. We need to get 20, so I'm going to put the 7 here and the 1 there. So if we distribute, we're going to get 21x and 1x. We need positive 20, so I want this to be positive, this to be negative. And now we have the product of two factors being equal to 0. So either 3x minus 1 equals 0, or x plus 7 equals 0. Let's see, add 1 to both sides here, divide by 3, subtract 7 from both sides here. So our solution set is either -7 or positive 1/3. Next up, we have 6x squared plus 19x plus 8 equals 0. So 6 and 8 are not prime, so let's use our grouping technique. Good review of that technique anyway. So 6 times 8 is 48. So we need factors of 48 that add to 19. So let's see. 16 and 3. Took me a second there to think about it. But 16 and 3, that multiplies to 48 and adds to 19. Perfect. Okay, so we'll replace 19 at x, so 6x squared plus 16x plus 3x plus 8 equals 0. Remember, the order you put the 16x and the 3x does not matter. We'll group the first two terms together, second two terms together. Greatest common factor of the first two terms is going to be 2x. That leaves us with 3x plus 8. There is no greatest common factor, so we'll just factor out a 1. And then we're left still with 3x plus 8. Now, 3x plus 8 is the greatest common factor of our two terms. So we have 3x plus 8 times 2x plus 1 equals 0. And now we have the product of two factors being equal to 0. So either 3x plus 8 equals 0, or 2x plus 1 equals 0. So we'll subtract 8 from both sides here, divide by 3. Here we'll subtract 1 from both sides and divide by 2. So our solution set is -8/3 or -1/2. So this is a nice example because we got to review the technique of factoring a trinomial with grouping, right? And as a reminder, we're looking for factors of the product of the leading coefficient and the constant term. So in this case, 6 times 8, which was 48. We're looking for a factor pair that adds up to the value, the coefficient of the middle term. In this case, that was 16 and 3. So we replace 19x with 16x plus 3x, and then we can use our grouping technique. Then we can use our zero product property and come up with our solutions. Solve each equation by factoring still. So -x squared plus 4x plus 77 equals 0. Now, I'd prefer to factor this with a leading coefficient of +1, not -1. So we can factor out a -1. X squared minus 4x minus 77 equals 0. We could have also chosen to move each term to the other side. So add x squared, subtract 4x, and subtract 77. That would be acceptable as well. Now we can factor, so we'd have x. So we need factors of negative 77 that add to negative 4. So it's going to be negative 11 and positive 7. So now we set each factor equal to 0. Well, I'll write it out, but technically we don't need to write negative 1 equals 0 because there's no x term there. But technically negative 1 is one of the factors here. X minus 11 equals 0. X plus 7 equals 0. Right, so as we said, negative 1 is not equal to 0. Here we'll add 11 on both sides, so x equals 11. Here we'll subtract 7 from both sides, x equals negative 7. So our solution set is negative 7 or 11. Next up, 10x squared minus 15x minus 25 equals 0. So we can take out a GCF, and that's going to make the factoring easier. So let's do that. We'll factor out a 5. 2x squared minus 3x minus 5 equals 0. So now we can factor our trinomial. We'll have 2x and x. So 5 is prime, so we either have 5 and 1 or 1 and 5. Let's see, I'll put the 5 here and the 1 there. We'd have 5x and 2x. We want negative 3x, so make this negative, this positive. So again, I can set 5 equal to 0, although we don't have to. 2x minus 5 equals 0. X plus 1 equals 0. 5 does not equal 0. We can add 5, divide by 2, so x equals 5 over 2. We can subtract 1 from both sides, so our solution set here is negative 1 or 5 over 2. Last example. Solve by factoring. Negative 8x squared plus 10x plus 12 equals 0. So let's take out a greatest common factor first. So that greatest common factor is going to be negative 2. And that will leave us with 4x squared minus 5x minus 6 equals 0. Our leading coefficient and our constant are not prime, so we'll use our grouping technique. So 4 times negative 6 is negative 24. So we need a factor pair of negative 24 that adds to negative 5. So negative 8 times 3 comes to mind. So we have negative 2 times 4x squared minus 8x plus 3x minus 6 equals 0. So we'll group the first two terms together, second two terms together. Greatest common factor of the first two terms is 4x. That leaves us with x minus 2. Greatest common factor of the second two terms is 3. Leaves us with x minus 2. That's all equal to 0. X minus 2 is the greatest common factor of the two terms that we get. So we have negative 2 times x minus 2 times 4x plus 3 equals 0. And now we can set each factor equal to 0. So negative 2 equals 0, x minus 2 equals 0, or 4x plus 3 equals 0. So negative 2 does not equal 0. Here we can add 2 to both sides, so x equals 2. Here we can subtract 3 from both sides, then divide by 4. So x equals negative 3 over 4. So our solution set here is negative 3 over 4, or 2. So one last example. Explain why the following quadratic equation cannot be solved by factoring. And the equation is x squared plus 10x minus 2 equals 0. So if we think back to our factoring unit, how did we show a quadratic could not be factored? Well, that was using the discriminant. And if we recall, the discriminant is equal to b squared minus 4ac. And if the value of the discriminant was not a perfect square, then that told us that the quadratic equation was not factorable. So if we go through that same computation here, a is 1, b is 10, c is negative 2. So our discriminant then is 10 squared minus 4. So we are looking for minus 4 times 1 times negative 2. So we have 100 plus 8, which is 108. So that discriminant is not a perfect square, which tells us, so not a perfect square, so not factorable. Right? The quadratic is not factorable, hence we're not able to solve this by factoring. Now the question is, how would we solve this? And that's something that we're going to look at in a few videos. That's something called the quadratic formula. So in this video, we kept it pretty simple. If you notice, all the equations started out equal to 0. That's not always going to be true as we transition into the next video. But what I wanted to focus on is the zero product property combined with all of our factoring techniques, right? Difference of two squares, greatest common factor, and our trinomial factoring. So before you watch that next video, practice solving equations, refreshing your factoring techniques, and then you can transition into some of the more challenging equations that we have to solve by factoring. Click the Amazon link down below for my algebra workbook so you can practice on your own. Give the video a like, and before you go, click that subscribe button so you can see more videos just like this. Thanks for watching.